Now let's discuss rotation constructions. To rotate a figure an angle theta about a point, we'll call it P, requires a compass and a protractor. Let theta, our angle of rotation, be 75 degrees and use it to rotate quadrilateral ABCD 75 degrees counterclockwise. To start, use the compass to sketch 3 circular arcs that pass through points A, B, C, and D. Be sure to extend circular arcs into the second quadrant so that we accommodate the requirements of the rotation, which is 75 degrees. Now, some of you may be asking, why does it say make 3 circular arcs? There are 4 vertices. Why am I not making 4 of them? Well, we can see that this arc that goes through C is by itself, but then if we bring our compass inward to this arc, we can see that this first arc that was drawn passes through points A and D. So when using a compass to do these sketches, make sure that every arc that you draw passes through at least one vertex. If you get lucky and it passes through 2, then you have 1 less arc to draw. Now use the protractor to measure 75-degree angles to map from point to point. In the figure below, the protractor is positioned to have point B coincide with 0 on the inner scale. Notice here's point B, and it corresponds with 0 on the inner scale, so we can line it up there. And then we're going 75 degrees counterclockwise, so we're going to use the inner scale, and we go right in between 70 and 80. And a way to get the exact measurement is once you're at 70, go out to 110 and then count 5 to the left. And that's how we're getting this point at 75 degrees. So this would be 75 degrees on the inner scale. If your protractor is a little smaller or a little bigger than the circular arc that has been drawn, you can also draw a point outside of the protractor and then remove the protractor and connect this point out here with the center of rotation point P. And then where this line intersects our arc is where point B prime will be located. And the point B prime lies on the same circular arc as B at the 75-degree mark on the inner scale as shown. Now repeat the process to map points on the pre-image to points on the image. In the figure below, the protractor is positioned to have point A be at 0 degrees on the inner scale. So we can see here's point A, here's that 0 on the inner scale, and then the point A prime lies on the same circular arc as A at the 75-degree mark. So here's where the 75-degree mark is, right here between 70 and 80. And again, you can go out to 70 and then count over 5 so that you have that exact value. And again, as I said, if your protractor is too big or too small, such that you cannot draw point A directly on the circular arc where it's desired, you can create a reference point out here and then draw a straight line through this point and point P, and then where it intersects that first arc, that will be where A prime is located. Continue using the mapping process. In the figure below, the protractor is positioned to have point C coincide with 0. So we can see here is point C and here is 0 on our inner scale of the protractor. The point C prime lies on the same circular arc as C at the 75-degree mark on the inner scale as shown. So we go out with this inner scale out to 70, and then we can branch out to 110 and then count over 1, 2, 3, 4, 5. So this 105-degree measure on the outer scale coincides with 75 degrees on the inner scale. So this is where we're going to put our point. Similar to before, if your protractor extends further or closer than the arc where you need to plot your point, then plot a reference point, remove your protractor, and connect your reference point with point P, and where the line intersects the desired arc that had point C on it will be the location of the new point C prime. In the figure below, the protractor is positioned to have point D coincide with 0 degrees on the inner scale of the protractor. So again, notice here is where point D is, and it coincides with 0 on the inner scale of the protractor. And then we're going to measure 75 degrees from this point. So if we go out, we can see the 70 degree mark goes here. And then we can go over 1, 2, 3, 4, 5 in the outer and draw a straight line in to where D prime lies. Similar to the others, if your protractor is bigger than the arc that you are using for point D prime, then plot this extra point right here that would coincide with the 75 degree rotation, and then remove the protractor and connect this point with point P. And once that line is drawn, where that line intersects our innermost arc, that is where point D prime will be located. Finally, we connect the dots that we've created for our image points with a pencil and straight edge to complete the construction. So take your ruler or straight edge, line it up with points A prime and B prime, draw a segment from one point to the next, then realign your ruler or straight edge to go from point B prime to C prime, and so on. Here's the final result after connecting the vertices for our image points, and its rule is given below. The rotation of 75 degrees counterclockwise about point P of xy will yield xy with a 75 degree rotation. Now let's look at some interactive graphics to help us better understand how rotations are executed. Click on the Desmos link or copy and paste this URL into your browser to bring up this interactive graphic. And we can move our variable around, and you can see how it's continuing to rotate counterclockwise. If we go in the reverse direction or the negative direction, it will rotate it clockwise. And when we're at 0, we are directly over the pre-image. And again, as you continue to increase the value of the variable, it's rotating in a counterclockwise manner.